All right, guys, so we've watched that other video. Now we're going to talk about our different types of solutions. So when we make a solution, right, we're going to take and we're going to dissolve some of our solid in that liquid, right? And so what we can form are three different types of those solutions. We can form a unsaturated solution, a saturated solution, or a supersaturated solution, okay? So an unsaturated solution, it can dissolve more solid. Okay, so if you have something like sodium chloride, right, and we add it to water, right, we're going to be able to form a solution, right? This is going to become a solution, and we're not going to see anything, okay? This is going to be an unsaturated solution because it could dissolve more sodium chloride, okay? But eventually we'll keep on adding sodium chloride, keep on adding sodium chloride, keep on adding sodium chloride. Eventually we're going to get to what's called a saturated solution where we cannot dissolve anymore. Okay, so if we think, right, about our molecules, we add some sodium chloride, right? So we've got something, right, like this. All right, we've got this solid, we add it into our water. Those water particles are going to interact with those NaCl particles, and it's going to pull them away, okay? So we're going to get new interactions where we've got our water particles surrounding our salt pieces, right? The Na or the Cl. Okay, so we're going to have these interactions with our water particles, and eventually we're going to have so many interactions that our salt, right, we won't be able to have any new interactions to interact with our NaCl. Okay, so that's when we're at that saturated point. Okay, but we do know that our reaction or our solubility is dependent on temperature. So if we have a solid, right, we can increase the temperature and we can make more of our solid dissolve in the reaction or in the solution. We make more of it dissolve in the solution, and then we can slowly cool it down, and we can form what's called a supersaturated solution. A supersaturated solution, we have more solute dissolved than is stable. Okay, so again, when we make a solution, right, we're going to separate our particles. We take those, we separate them out, right? All of these particles are separated from each other. Okay, they get separated when they dissolve. So if we make a supersaturated solution, we get lots of those particles dissolved. They get separated by those water particles. And then if we slowly cool them down, the molecules don't start just meeting each other right away, right? It's not stable. It wants to form a solid, but we have more particles, right? They have to meet to actually form that solid. Okay, so this supersaturated solution, right, we heated it up, we got it really concentrated, and then we slowly let it sit. Those particles don't meet, and then we can do something, and all of those particles will meet, they get real close together, they form that solid. Okay, so that's that supersaturated solution. Okay, we have more solute dissolved than is stable. Okay, so let's think about these situations. If we have an unsaturated solution and we add crystals, right? Unsaturated, it can dissolve more things, right? It can dissolve more of our solid. So if we add crystals, we will see them disappear or dissolve. Okay, so that means that the rate of dissolving is faster than the rate of precipitation. you have a supersaturated solution, right? Supersaturated, we've got more solute dissolved than is stable. You add crystals, well, we're going to see a precipitation reaction, right? We'll start with a little crystal and we'll form more crystals because we're going to be taking some of those solute out of solution now, okay? So we will see that the rate of dissolving is slower than the rate of precipitation, okay? But if we have a saturated solution, we add crystals, what are we going to see? Nothing. Because the rate of dissolving is equal to the rate of precipitation. We have that precipitation and dissolving reaction occurring at the same rate. Okay, so we could represent this with something like NaCl solid, right? Forward reaction, dissolving, backwards reaction, precipitation, forming Na plus aqueous and Cl minus aqueous. Okay, so our forward reaction would be our dissolving reaction, and our backwards reaction would be our precipitation reaction. When we have a saturated solution, these two rates are equal to each other. Okay, so now this is where we really want to understand what's happening. Okay, so this is a solubility curve, right? We have different temperatures and our solubility is dependent on those different temperatures. Okay, so if we think here, we have certain ones that are going down as we increase the temperature. SO2, NH3, right? HCl. These are gases that the temperature increases, the solubility decreases. We have other compounds, right, like KNO3, NaNO3, Ki, right? These, as we increase the temperature, we increase the solubility, okay? So our table here shows the number of grams of a substance that can be dissolved in 100 grams or 100 liters or milliliters of water at temperatures between 0 and 100, okay? Each curve represents the maximum amount of a substance that can be dissolved at a given temperature. All lines that show an increase in solubility as temperature increases represent solids. The lines for gases slope downward, okay? So, right on that line is our saturated solution. If we are below that line, then we are unsaturated, and if we are above that line, we would be supersaturated. So, on line, saturated, below line, unsaturated, and above the line, it is supersaturated. Okay, so we want to be able to use this table and read this graph. Okay. Oh, I basically just wrote that down there, but I summarized it up above. Okay, so we want to be able to understand and read this graph. That's what we want to be able to do. Okay? All right.